So today we will be finalizing what we've been working on with the pneumatic tubes last week and a few weeks before that. And before we finalize that, we're also going to do some spline math. And I'd say so we're going to finalize the tubes. I think all that's really left is to just do some collection service stuff to like recognize the tubes and then build them and then actually like construct them in TRS, between waypoints. So that's all that there is for that, and then we can start with the math. So last week we discussed the form of the spines that we're working with. We said it was a function, as a vector valued function R of t, and it's composed of three individual functions, x of t, y of t, and z of t, and together they make the 3D curve, the space curve. And we can draw a space curve, so something like this, and I'll also just draw some axes so that we're aware that this is in 3 dimensions. And this is R of t. But given this curve, we can also find out more about it. So one thing that we can do, actually, I've drawn this upside down from the way I wanted it. Okay, so let's see, given a point here, something that we can find out about it is the tangent vector. So that's here, so we'll call that t of t. And then in addition to the tangent vector, we can also calculate a normal vector. So this is a normal to the curve, and it points in the direction that it's curving. So and here it's pointing. Well, I'm not sure how else to describe that, but like if it was over here, the normal is in that direction. And then the last thing that we can calculate about
You say
this curve.
You say the normal, but it's actually a plane.
Oh,
right?
it's a normal. You're right. Yeah. So there are infinite amount of normal vectors around the curve. I guess. So what's special about this one is that it points in the direction of, like the direction that the curve is curving in. I'm not sure how else to say that.
Sure. I guess we'll see when you define it. Yeah.
Okay. And then the last thing that we'll define is a vector b. We call this b for binormal, and b is perpendicular to both n and t. So all of these vectors here are mutually perpendicular. All right, so the definition for t is as follows. So t is going to be, I guess conceptually, it's the same idea as with a tangent in calculus, where a tangent to a curve is going to be its derivative, and that's exactly what we see here. So the tangent vector is going to be defined as the derivative of the position, and then we're going to normalize it. So to normalize it, we'll just divide it by the magnitude of the derivative. Or in other words, we could say that it's just kind of shorthand it. It's the unit vector with the hat. So that's the tangent, and then normal is going to actually be, we're going to continue the same thing. So the definition for the normal vector is going to be the derivative of the tangent vector. And then again, we'll normalize it. So something like that. So that's the tangent and the normal. And then the binormal, you might think we continue this pattern, but actually we just do a cross product. So the binormal is going to be the tangent vector crossed with the normal vector. The cross product gives us a perpendicular vector, and that's why it's the binormal.
Maybe it's worth noting that it's not obvious that the second derivative, or the derivative of the tangent vector, is going to be perpendicular to the tangent vector. It's a little exercise, I guess, one typically assigns in a vector calculus or second calculus course. But yeah, that works.
Yeah, that is true. I haven't taken this in 3 years, so I honestly couldn't tell you off the top of my head. Okay, so that is the tangent normal and binormal. And the importance of this, at least in our context for the pneumatic tubes, is that we want to be able to move a person along our tubes. And to do that, we're going to need a C-frame because we're going to need to C-frame the player. And a C-frame is composed of a look vector, an up vector, and a right vector. And those are three mutually perpendicular vectors. And this is exactly what we have. So we have the normal, tangent normal, and bivector. And so this is a natural, like a natural pick for what we're going to use a C-frame for. And I guess I should have defined these. So the T, N, and B, these three together, we call this, this is a Frenet frame, where the frame here is in the same sense of a C-frame, where it's a coordinate frame. So it's a frame of reference. So this is a natural pick for the C-frame that we'll use for the tubes. And I'll show you a demo of this. So this is the place that I use to demo all of my Catmull ROM stuff. And one of the demos I use is the tangent normal and binormal. So the tangent is in green, the normal is in blue, and then the binormal is in red.
You know what? The next time I teach Calculus 2, I'm going to show this. This is really useful.
Yeah, it's a lot of fun to like make these graphics.
What happens? Why is there such a discontinuous change in the at that point?
Right. So this is exactly why Frenet frames is actually not what we want to use. That was kind of going to be what I was going to say next. So because the normal points in the direction that it's curving, so when there's an inflection point, the normal just flips, which is not what we want. So sometimes, like here, the inflection point is kind of like it's like an instantaneous switch almost.
Oh,
Whereas here, it's
yeah, I see. It's partly because we normalize them, right? So actually, they're shrinking and then coming out the other side. Perhaps, I don't know if that's accurate.
yeah, that's exactly what's happening. So the normal vector actually becomes 0 at the inflection points. Yeah, so here it doesn't immediately flip, but it still twists quite fast, and so that's not really desired. I mean, it's kind of already a hazard to be using the pneumatic tubes, but if we could minimize the damage caused to our patrons, it would be.
Or their dizziness when they hop out the other end.
Yeah. So Frenet frames, not ideal. What we can use instead is called a rotation minimizing frame. So I guess if we want to give our riders the best ride, maybe we jostle them the least. A rotation minimizing frame sounds pretty good. All right, and this has been studied since earliest paper I found was like 70s, but I found a recent method for this that's kind of geometric and easier to understand. So I've created a demo for this. Where is it? Okay. Cool. So we have these points A and B, and the idea is so okay. Let me back up first. Our problem statement is that we want some frame of reference going around the curve that minimizes rotation. And this is going to be a continuous thing. And so I've read is not easy to compute. And so what we have to do is we have to approximate it at at different steps. And it's also iterative. So you have to calculate this if you want to know the frame of reference at one point, you actually have to calculate a bunch before it to know it. All right, is there anything else? Right, so what we're given is an initial reference frame. So I've just chosen the normal, the regular normal. So this is our initial reference frame that we're basing the rest of the frames of reference off of. And then we're also given the initial tangent, or really the tangent across the whole curve because it's not hard to compute. And then we want to do this at a fixed step. So if we want the the frame of reference at the very end, we have to do a bunch along the curve, and so we'll consider this to be the first one. So we'll demonstrate one iteration of this process. And this particular calculation of the rotation minimizing frame is called the double reflection method. And so we'll see why it's called that real soon. So starting at A, we have B, and we want to calculate a better normal than this blue one here, because you can already see this blue one is very different from the original normal. That's quite a quick twist. So we want something better than that. So the first step is to define this reflection plane. So this reflection plane is halfway between A and B, and it points from A to B. All right, and the next thing we do is we reflect the normal of A and the tangent of A across this plane. So that's what these translucent vectors are. So if I zoom out, we can see the reflection of it better. So first we reflect those. Cool. And then all I've done is just solidified it. So then the next reflection comes between the two tangent vectors. So this reflection plane is defined between the tangent vector of B and then the reflected tangent vector from A. So we define this plane, and then the vector that we reflect across this plane is going to be the blue, the dark blue. So we reflect it. Wait, oh, I'm wrong one. Reflect it, and we get this red vector. And this is what we're left with. So this is our minimal normal. Yeah. So this is like our normal vector that has minimal rotation. So I guess I'll step through that again. So just we have one reflection plane, we reflect the normal vector of A, then we have a second reflection plane, and we reflect it again, and that's our final solution. And this looks like, if I slide B around, this looks pretty good. This red isn't sort of discontinuous in the same way that the blue one is. But like I said, actually, what we want is to do this iteratively. So ideally, what we'd have is we'd have B close to A, and then we'd have another C next to B, and we'd keep doing it across the curve. And if we do that, we get this. So I've calculated the frame of reference across the whole curve, and this is what we get. And we don't have the same discontinuity in the same way that we do with the Frenet frames.
That's interesting. I've never seen this construction before. So I'm not asking you to provide a proof, but is there some asserted, what's the actual formal assertion that this is, I mean, is it just in practice smoother, or it actually has some property, and if so, what is that property?
I think the best I can tell you is just based on the name, that it's minimizing rotation.
And this is in the limit of what? Keeping, I mean, what is actually iterating? I guess I didn't follow what the iterative construction was exactly.
So the process that let me move this back. The process that we did here to like get this red vector, that's one iteration. So then we can do this again, so the red becomes our starting normal vector, and then maybe we'd have a point C to the right of it, and we'd do the double reflection again. We double reflect the red vector to get a new one.
Okay, and then in the limit where those steps are infinitely small, I guess you can prove that actually that's a continuous or smooth family of frames, probably.
That's right, yeah.
That's very interesting.
Okay, so let's find our agenda. Right, that's what we had for the math today. We could also implement this, but I think I will do that on my own time because I really want to get the tubes actually finished in the rising sea. Okay, so this looks a little different from where we left off. I did a little bit of work off camera. So this is where we were last time. I just so this map here is actually an old classic from Roblox. This is like 14 years old. Um, I just thought it looked cool, so I imported it.
Yeah, very cool. I like the trees.
Yeah, that's how we did it for many years. Okay, so the first thing we want to do is we want to have the ability to um, find tubes using collection service and then construct them. So pretty much what we need, we have to like pack all of this logic inside of collection service item added function because we've only done it for one here. So we need a collection service tag for the tube. Let's see, do I have the plugin? I do. Oh, and I have the tag. Okay, so we'll tag this as tube, and maybe we'll rename this to like. Is it cheesy to call it meta tube? Do we just call everything meta?
I don't know. It's not like there's a lot of thought behind these names. I think that's fine. Yeah.
Okay. All right, so we'll call this a meta tube. I think we'll just start clean here and then copy and paste in what we need. Right, and we need a function for when a tube is tagged. Okay, there it is. Yeah, get instance added signal. And then we also need to do it for any existing tubes in the world. Okay, and then when we find a tube, we can pretty much just copy and paste a lot of this in. So we need the parts of the tube. And then collect the points. And then we call, oh, right. So we also need our module that we created. Yep. And we need the player. We also need the player's controls.
Looking at this part that says, if not root part, not humanoid, I thought there was a discussion last time about sliding things that weren't players. Is that right? Oh, but we're assuming that maybe they're ghosts or something, but they're still humanoids.
Oh, so right. You can still do that. You can still slide anything using the module. This specific thing is just for the character. So this should be good. Yeah. Okay. Let's give that a run. So just to make sure it works, I'll copy this. So we'll have two tubes. Hopefully we get two. All right, cool. So we do. So the tagging works.
I want to see you go through that second one and slam into the building. It's just going to slide you straight through the building, I assume.
Yeah, I think, yeah.
You'll be fighting the collision detection with the C-frame movement, I suppose.
Let's see. So delete that. Yeah, okay, it does go right through. Oh, I almost just missed. Okay, that was actually really easy. I'm trying to think if there's anything else we need before we can just drop this in TRS. Oh, here's something. I commented this out. So I'm messing with the camera a little bit. Here, I'll show you what it does. Oh, that's oh yeah. I guess that didn't do what I thought it would do. But I thought the camera on rails effect was kind of cool, but it also didn't follow the player that much.
Yeah, that watch is not doesn't seem to be actually do what is documented. I was playing with that as well. It's I saw
What else do we have? Oh, sorry, what were you saying? I don't think that did anything. Oh well. All right. I think a camera on rails would be cool, but maybe not this. Yeah. Oh, and then another thing I added, when you come out of the tube, it just flips your C-frame around so you land on your feet. This is also something that you can see in the original Futurama video, except you start legs first and then you come out head first and Fry smacks the wall with his head. So we're a little nicer. We actually flip them the right way around. All right. I guess one other thing we need is the ability to load tubes. So when we load tubes, we have to do that on the server because it comes from a data store. So then we need the right. So we're going to load the positions of the nodes from the data store, and we're going to create parts at those positions, and we're going to tag those parts. And then the client should receive that tag, and then the code we just wrote should automatically create the tube. So I guess we'll, yeah, sure, we can do that. I guess we can do the data store code later because I don't really know what format it's in, but just given the points, we can create parts and tag them, and that should suffice.
Yeah, you can do it later, or you can just copy and paste from our meta boards, not in this demo server.
Yeah. Yeah, sure. Oh, yeah, we actually don't need the C-frames, and in fact, in the tube module, we don't need to use the C-frames either, so where do I do that? Oh, I was messing with the points, trying to get them to look nice. I'll mess with that later, but yeah, we don't need the C-frames, we just need the positions.
Then I think you'll have to roll your own serialization for vector 3s, so that has to be a little routine here, because if you want to use the JSON encode from HTTP service, you can't pass it a vector 3.
Oh, alright, yeah, I guess I also need to deserialize. Okay. Um, I'm just gonna leave that till later, 'cause I don't really know what to do for that. All we're doing now is, creating the parts, and then here we tag the folder, add tag to the instance, which is gonna be the folder, and then the tag is the tube tag. So we put this in the workspace, and then the client should see this tube, and then the collection service logic will see the tube and create it.
You want to add the tag before or after it's parented to the workspace? I guess.
I don't think it matters. Because I think the item added function will fire whatever order we do it. All right, so let's hop over to TRS. Oh, I actually had trouble opening TRS earlier. Oh, sweet. All right, so where do we want tubes to?
Yeah, I don't know. At the moment, the main place that one has to walk, and it's a bit of a chore, is up to the top of that little mountain, right? So maybe one could go somewhere. I don't know where you'd want to hop into it, but that might be the place it pops you out.
Right. Would it be an eyesore if it just started here and then went into the sky?
I think that's fine. We can always move it if we want, so it doesn't really matter for
Okay.
now.
I'll have it go through this hole. And...
That'll be cool.
Okay. All right. Just the front. There it is.
Is there some magic key you can press that will change the orientation back to the standard one when you're dragging things around like that?
Oh, I just go to the orientation thing and... Oh, you guys can probably hardly see what I'm doing. I forgot to turn my monitor resolution down. Okay. Okay. Does this loop through? Oh, that would kind of block the walkway.
That's okay. Nobody goes up there anyway.
Okay.
Everybody just jumps up the cliff, so that's cool.
All right. And let's drop them over here on this rock. All right, and then the most annoying thing about this process is that I have to name all of them. Also really easy to like have a bad curve and then you have to add a point in the middle and update all the names. I kept having to do that for the skyscraper. So I guess the saving grace to that is that I have a friend working on a Catmull-ROM spline plugin. So that's who needed all the updated math that I've been doing the past couple weeks. So I guess whenever that is out, we can use it.
Alright, cool. How would that make this process easier? Did you just have
for one to...
2 8s? Oh no, it's a 9. It's just my resolution. Right?
Oh, that would be bad. Yeah, I think the plugin should just make placing them easier, and also you can see the curve, what the curve looks like beforehand. Yeah, all right, so let's tag this. And then drop in the code. Oh, and while I'm here, I'll delete my firework code.
I didn't have a chance to steal it yet. Oh no.
Oh, I'll leave it there.
That's okay. Just
Okay.
I'm gonna I'm going to muscle in on your end of year celebration market. I missed
People
it.
try.
I missed it on last year. Had we met at that point? Maybe not. I can't remember.
I think we knew each other, but like not well. Oh yeah, because I've been attending since October.
Right. Yeah, Russell and I'll definitely show up at the end of this year. That'll be cool.
Okay. Oh, that's a good sign. It immediately aired. Oh, I didn't copy over. Oh, the module, duh. Oh, and I need cat ROM.
Wow, first try. That's
Yeah.
cool.
Oh, you know, something that would be nice, as like an attribute, defining the colors of the tube.
Yeah, I was wondering about that. What's a mesh part here that can't really be changed in terms of its color, and what isn't? The tubes themselves, they were mesh parts now, right?
Yeah, everything's a mesh part.
But the colors are still available to be changed in code, right?
Yeah, I mean, even unions, you can change the color of a union too.
Yeah, I thought it would be cool to have some tubes in deprecation with a kind of black and white color theme as well. Yeah, I think.
Yeah, for sure. All right, so call this tube color. And then we also need the ring color. Oh, okay. So this is something that's going to have to happen inside of the tube module because that's where we create everything. So then we might also have to pass in the colors. So we have tube radius, tube length. I think at this point where we have like 6 inputs, I would just move to a dictionary to make it easier to remember the order of things.
Yeah, I never quite know the conventions around that in this community. I found myself doing that a few times as well, but it seems I don't see a lot of this in other code that I read. Is this something that people typically do, or?
I don't think so. It's something I started doing looking at somebody else's code, and I think it should be done more. So we're going to need prop stop points. I'll fix the indentation. And then all right, and then the two that we want to add is the tube color and then the ring color. All right, and then we can get rid of this. Fix that. Okay. And then for the tube color, we're going to want to pass that into. Oh, okay. So I split up the tube creation process into 3 functions: create tube, create joint, create ring. So we'll just pass it into there. So for the tube, we're going to need the tube color. For the joint, we'll also need the tube color. and then the ring. So here it'll just be the color sphere.color and then tube.color. And then pass those in. So create tube, pass in tube color, ring takes ring color, and joint takes tube color. Oh, but we also need defaults. So default tube color is, I think I'm using bright blue. And then the ring is a special color 3 and find that. So the ring is this guy. So we'll do tube color or the default. And then same for the ring. Oh, and then similarly, this tube radius also has a default, so we'll just move that up. And then same for the length. Cool. And then we also need to change how we call it. So here it is, right? So when we do tubes.fromPoint, we need to pass in a dictionary instead. And then for tube color, we're going to need to do, right, so it's going to be tube get attribute. And then same for the ring color. All right, let's see how that works. Almost. I forgot the entrance.
Curious with there's some level of transparency at which it decides not to adjust the camera to get inside whatever the obstruction is. Was that something you tweaked with the tubes to make sure that worked? Or, I mean, if they were fully, if the transparency was zero, would the camera do a very different thing?
Yeah, that's probably, so that's not something I did. That's probably inside of the camera code. Here it is. So let's see. That would be probably the popper cam. Okay, I'm actually not sure. I'd have to look through it, but it's somewhere in here. It's not something that I control. Okay, so we have to fix the color and then also these nodes on the screen. We might as well just make those transparent. Okay, and then for the colors, we also, all right, here it is. So the entrance, and then I think I also, no, that's right. Okay, so for the entrance, we need to change entrance as a ring. Has a tube. Oh, that's not the entrance. I meant to look inside the entrance. Okay, so the entrance has the cap. It has a tube. It has 2 rings. So I'll probably just name those ring 1 and ring 2. Oh, okay, yeah, ring 1 and ring 2 is fine. Let's give that a go. Last thing I forgot to do was change the entrance's color, or change its transparency. All right, there we go. So I'd say that's pretty functional. I think the last thing we need really is just data store stuff.
Yeah, I guess given the time, maybe we can leave that for another day.
Yeah, I'd say this is a good place to wrap up.
Yeah, that's great. Now, how much does it cost to travel through the tube?
10 Robux. It'll be a dev product.
Very good. Thanks a lot, Ethan. Maybe you should publish it, and we can end the stream by jumping in and having a bit of a go.
Oh, yeah, yeah. I can't do it. I can't leave it empty.
Leave what empty?
Oh, the commit message.
Good man.
All right. I'll leave I'll put the link in code so we can all join.
Oh, I already pasted it into the MetaUni Day channel.
Oh, sweet. Wait, no, did that not work? Oh, you're too tall?
I can see myself going. You can't. It's not working.
Oh, wait, I couldn't see you going.
Oh, that's interesting. Okay. Okay, you go in and I'll watch on the free cam. Oh. No, I just saw you get teleported to the end.
Yeah, okay. That's not... I think what we might have to do is move the player with physics. So we might have to use an align position and align orientation. Yeah, I mean, we have physics ownership over our own client. I think it's the fact that we're setting the CFrame as opposed to using a physics object. Oh. Actually, I don't even know why I was using or wasn't using pivot 2. But I think it should be I think it would be the same thing. Yeah, I think, I'll mess about with it on camera. I mean, off camera.
Yeah, I think this is a good place to stop. It looks cool anyway. Actually, I like this current color very much.
Yeah.
Stylish. It fits with Adam's appearance of a killer robot somehow. You walk into the scary black tube and get delivered to the killer robot.
Oh my god, yeah.
to his hideout. Alright, thanks a lot, Ethan. I guess we'll wrap up the stream there. We can continue discussing, but I'll stop the recording.